Good morning. Today we'll be starting another chapter of immunity. So now there are three levels of immunity. There's a first line of defense in the human body, there's a second line of defense in the human body, and there's a third line of defense in the human body. So firstly, immunity is the ability of the body to recognize a foreign body or a pathogen and then mobilize the cell products or the immune or cells to act against that foreign material or pathogen. So, as we talked about the three lines of defense, the first line of defense is the human body, is the human skin. Now, microorganisms naturally cannot pass through the human skin and they cannot penetrate through it because of the thick layer of keratin on it. However, if there is a wound and if there is a rupture of the epidermis of the skin, then invading organisms such as bacteria can pass through that and give rise to various types of infections such as abscesses and boils and carbuncles, etc. Now, the second line of defense, within the first line of defense, the other things are the mucous membrane, which are in the human mouth, as well as in the nose. And we all know that how dust particles that are trapped by the hair in the nose of the humans. Similarly, the mucous membrane traps the bacteria or the oral flora and prevents them from going within the GI alimentary tract and reaching the digestive system. Also, the sweat, which is released in the form of sebum from in the armpits as well as all over the body it contains certain chemicals. It contains lactic acid, which inhibits the growth of bacteria and fungi, and thus it is responsible for the staunch odor, or the foul-smelling odor, which is released when the bacteria and fungi are killed. Similar, in the elementary canal, the HCl has an extremely low pH of 2. The most bacteria are unable to survive within such a low pH, and thus the body has an extremely low pH. So to basically it will help the keep a check on the quality of the microorganisms. The second line of defense in the human body is the inflammatory response of the human body towards the pathogens. There are several responses, including fever. However, we'll be studying them on a systematic base. So, firstly, what are macrophages? Macrophages are antigen-presenting cells. This means that when the pathogen attacks them, they bring down the pathogen and displace some pieces of the pathogen on top of them, so that the other the body substances can recognize the pathogen and can easily distinguish between normal physiological body parts and the pathogen and can attack it. So therefore the role of the macrophages is as an antigen presenting cells and macrophages help T helper cells to attack basically. So the T cells are dependent on the macrophages, I repeat. These all wake up the responses, wake up the immune system. Now, neutrophils, as we talked previously as well, that neutrophils have basically pseudopods which have amoeboid movement and they kill the microorganism by releasing enzymes. So the enzymes which are released are basically elastases and lysosomes and etc. Now, natural killer cells are type T helper cells. What they do is that they make basically holes or with the inside the bacteria or the pathogen, and through them they release perforins, which are basically toxic to them. So this is how the microorganism undergoes apoptosis. Now there's an extensive system of the body known as the complement system. The complement system comprises of two pathways, the extrinsic pathway and the intrinsic pathway. The most important protein of the complement system is the C3 protein. The complement system is responsible for the various mediators we talked about in the previous chapters, including histamine and bradykinin. They basically help also to mobilize all the other neutrophils and monocytes and macrophages, as well as the release of inflammatory mediators such as histamine and bradykinin. Now there are basically levels of the complement system. First is cell lysis. Lysis means simply killing the cell. Oxidization. Oxidization is that the bacteria basically are presented on the top of the cell and then they are captured on it. And finally, immune complexes, in which their antigen antibody complexes are formed, and they are basically engulfed by the phagocyte and then they are eaten by it and later destroyed. Now is the role of interferons. Interferons, there are many different frauds which are used in chronic as well as acute inflammation. However, in acute inflammation or acute attacks, the most important interferon is interferon gamma. Now, the four cardinal signs of inflammation. The four classical signs of inflammation are heat, pain, redness, and swelling. You just need to remember these. As we talked previously as well, what is the role of increasing the body's temperature as a line of defense? Microorganisms cannot survive usually at temperature above 100 degrees Fahrenheit, so the body hypothalamus increases the body's temperature above 100 degrees Fahrenheit in an attempt to kill the bacteria. However, it is a careful increase, as increase of about over 107 degrees Fahrenheit can also kill the enzymes and permanently denature them. Therefore, there has to be kept a balance. The final line of defense, or third line of defense in the human body, is the antibodies which are produced. There are two types of antibodies, as previously talked as well. The humoral antibodies released by the B cells and the T lymphocytes, which produce helper T lymphocytes. The T lymphocytes are involved in the cell-mediated response. Now, there are two types of lymphocytes, CD4 and CD8. CD8 are involved in simply killing the microorganism. However, the CD4 helper T lymphocytes release interleukins, which help with the proliferation of both T and B cells and to fight the pathogen. Now we'll be talking about, we've already discussed the mechanism how these T lymphocytes work. You just need to know that where they are made. So the T lymphocytes are made in the thymus, as they stand for T, and B lymphocytes are obviously made in the bone marrow, as they stand for B. Now, further, B lymphocytes basically mature to form plasma cells, which produce antibodies. So you need to know that plasma cells are the further subdivision of B cells which produce antibodies. Now, there are five types of antibodies: IgA, IgE, IgG, IgM, and IgD. IgE antibody has a role in basically the secretions. You need to know the secretions, for example, tears and in the mucous membrane. The IgE is involved in inflammatory responses, such allergic or the allergic responses such as an asthma and other allergic responses such as anaphylaxis. The IgG antibody was responsible for complement. You need to know that only two antibodies, IgG and IgM, are responsible for complement fixation, and only one of them can cross the placental barrier. The IgG antibody is basically can cross the placental barrier. Now, you need to know that the significance of the two most important antibodies written over here are IgM and IgG. Whenever a person has an acute infection, for example, of hepatitis, the first antibody, which represents that the infection is ongoing currently, is IgM, and it is the first type of antibody which is produced. However, after a person is cured, a person will no longer have the disease as he this is represented by IgG. So when a person, you need to know that when a person is all right and when a person after is recovered from the illness, he displays the antibody IgG. Also, the most common antibody in the human body is the antibody IgG. Now, if we talk about the structure of the antibody, there are two types of the structure of the antibody. There are two types of chains, a variable chains and constant chains. So you need to know that firstly that the antibody are linked by disulfide bridges. And these disulfide bonds or double S bonds are help to link the two antibodies. But there are two, as we had talked previously as well, that The variable chain, you need to know that the antigen always binds on the variable chain or not on the light chain. So the variable chain is the antigen antibody binding site. Now, how antibodies work, we already talked that they neutralize the microorganism that cause agglutination or clumping of the microorganism and the activation of complement system. There are two types of immunity. This is frequently asked these the differences between the two. We need to know that innate immunity is that type of immunity which is naturally present in the human body. For example, when the fetus or the baby drinks mother's milk, so he gains antibodies from the mother's milk, fight the pathogens. The innate immunity is the most for innate immunity is basically specific code is specific, and it is the most quick form of immunity. Now we need to know that adaptive immunity, on the other hand, is all if a person has acute infection, adaptive immunity is more rapid than innate immunity. However, and we need to note that since innate immunity is only specific to a certain thing, the adaptive immunity is highly diverse, and its response time takes days. Now, if we talk about the acquired immunity, there are two types of acquired immunity: active immunity and passive immunity. Active immunity is the type of immunity present in vaccines. For example, the killed or weakened form of a pathogen. Killed form of pathogen is used, for example, in vaccines such as polio, and or a highly weakened form of pathogen is used so that the body can basically fight it and help and develop more plasma and memory cells so that the next time an invading pathogen comes, the body knows how to fight it. This is the purpose of active immunity, and this is used as artificial active immunity. Now, I've already talked to you about natural passive immunity in the colostrum, and now we will talk about the artificial passive immunity. Now, cases of artificial passive immunity include one, for example, a dog bites. So you need to have if a person does not have had the has had the rabies vaccine, a person needs to develop a quick response to the bacteria to the virus. So there is an antivenom serum. So the antivenom serum has both as passive as well as active immunity, as it has both the vaccine and as well as passive immunity in the form of antibodies. This is the most appropriate response. As a person without rabies vaccine, and if he does not get the antivenom serum, he will most likely die. These are some of the differences listed between active and passive immunity. That passive immunity is natural and passive immunity is immediate. That's why in case of, for example, dog bite, passive immunity is preferred in comparison to active immunity, which is delayed. Thank you. This wraps up our chapter on immunity. I hope to see you in the next lecture. Thank you.